In this video, we're going to kick things off by setting up our game's project, and we're also going to handle the creation of the actor class. So, to get started, let's create a new project. We'll jump all the way down to XNA Game Studio 3.1, and we'll name this project Behavior Demo. Behavior Demo. We'll hit OK and get the project created. Now we'll give it just a second to load everything up. Now as soon as the project does load in, there is one texture asset that we need to import. So now that everything has loaded up here inside of Visual Studio, I'm going to begin by jumping out here to the file system where I have this arrow graphic. Very briefly, we could load up this graphic and take a look. This arrow is simply a triangle that we've used since direction plays a key role in this demo. We want a graphic that will show which direction a given actor is pointing. So we've chosen to go with this triangular shape. One other thing I will briefly note is that this graphic was created with the graphic pointing in the up direction, and this means when we're actually drawing the direction using some vector math, we're actually going to have to rotate this a little bit. Since you could call it our circle start is going to be pointing out here to the right, so we've got kind of a 90-degree offset. Just pointing that out now, so later when we go and add a various fraction of pi offset, that will make a little bit more sense. But knowing that this is the graphic that we need in place, let's take this arrow.png graphic and drag it directly into our Solution Explorer and drop it onto the content project. This will get the arrow graphic ready to go with all of the settings necessary to have it compiled into a texture asset inside of XNA. Alright, with our texture out of the way, there are a few fields we need to take care of inside of the game class. Since we need to be able to check the bounds of the screen whenever actors are moving around, we need to record the size of the screen. So what I'm going to do is make two integer fields here in the game class, and we'll call these screen width and screen height. So we'll begin with the first, which is int screen width. We'll set this to a value of 800. We'll make a second integer field called screen height and set this to 600. Of course, here we're just using the default resolution of an XNA game, but the idea is that we have two quick fields we can always reference, plus this will allow us to very quickly change the resolution of our demo at will. Now, to make sure that these do get taken into effect in case we change them, let's make sure that we set up our graphics preferred back buffer width and height using these fields. We'll do that inside of the game's constructor. Right after the graphics device manager gets created, we'll turn around and use that graphics device manager by accessing some of its fields. Preferred back buffer width will be the first, and that will be set to the value held in screen width. Now we need to do the same thing for screen height. So I'm going to grab this line for setting back buffer width, copy and paste it to duplicate it. Only this time the field that we're interested in is preferred back buffer height, and the field that we're going to copy is screen height. So all very simple, just making sure that our fields get tied in. Now, for the purposes of this demo, we want to show a few different kinds of objects. We'll have a main leader actor, and he's going to be a specific color, and we're going to have other types of actors like obstacles, drones, and enemies. Now, I've come up with a color scheme to represent these different kinds of objects, and these colors look best on a different background color other than the default cornflower blue. So what I'm going to do is change the background color for our game by scrolling down here to the draw method, where we'll remove the color cornflower blue and replace this with a new color value, and we're going to specify the red, green, and blue components ourselves. For red and green, we're going to set values of 96 and 96, and for the value of blue, we're going to set the value 111. So just a brief visual example of this. Let's run the game just to get an idea of what color we're working with here now. You can see that this has resulted in a kind of bluish gray for our background. Alright, with some of the game basics out of the way, let's turn our attention to the actor class itself. Let's begin up here in the Solution Explorer, and we'll add a new class directly to the Behavior Demo project. So scrolling down here to Class. For the class name, we'll simply call this Actor. And we'll give it a second to load in our new actor class. Now, in this video, we're only going to take the actor as far as the actor by itself. We're not going to worry about actual behavior integration just yet. We just want to show the tried and true example of multiple actors, all with a life of their own, moving around inside of a scene. So, for the actor class, before we actually get into the class, there are a few using statements we need to take care of. So we'll drop in a using for Microsoft.xna.framework and a second using statement for framework.graphics. Alright, so moving on to the actor class itself, there are a handful of fields that actor is going to need in order to be able to manage its instances, and a few fields that we'll use to manage all actors currently in the scene. We'll use a handful of static fields inside of actor to manage all of the actors currently in existence. So in essence, the static fields of actor will also consist of the scene that holds our actors. So in order to manage all actors, we're going to use a list. So we'll make a public static list, and this list will be of type actor, and we'll call the list actors. Then we'll turn around and initialize the field using a field initializer. So we'll have actors equals new list of type actor, and that will take care of our actors list. Now we're also going to need some random positioning and directional settings. Basically, when we're spawning actors into the scene, we're going to do so by setting them at random locations pointing in random directions. So to do that, we'll be using a random object. Rather than recreate one every time it's needed, we'll simply store a reference to, store a static reference to a single random object. So we'll make a private static field, and we'll make this field of type random. We'll call the field random, and we'll set it to be equal to a new instance of random. Alright, that takes care of our static fields. Now we need to put together a series of fields that will describe the individual actor instances. These will be things such as color, texture, position, direction, speed, and origin. All of these fields we will leave as public just to make the actor very easy to access from anywhere else in code. Again, this is just a simple demo, so we're not going to worry too much about what types of fields to protect, what types of fields to hide behind properties, and so forth. Alright, beginning with the first field, which is color, we'll make a public field of type color, which will be called color. Second field will be texture, so we'll have public texture 2D, which we will call texture. Next up, we'll have our position, which will be a public vector2, which we'll call position. Next, we'll have a direction, so this will be a second vector2 called direction. Then, in addition to direction, we're also going to store speed as a separate value, which means we'll have an additional field, a public float field called speed. Now, just a quick note on the idea here with the direction and speed. Direction is intended to be used as a unit vector here inside of the actor class. We'll use this vector to point in a specific direction. We'll actually use direction in conjunction with speed to figure out how fast and in what direction to move the actor. More specifically, when we're updating position, we'll update position based on both speed and direction. Alright, one final field that we need to store is our actor's origin. So we'll make a public vector2 field called origin. And we'll simply use this field when we're drawing our actor so that we can draw the actor centered around the center of the texture. Alright, moving on from here, we have a handful of methods, both some static, some instance methods. We'll begin with the instance methods with the public constructor of actor. So we'll begin down here with public actor. Now we're going to set up our actor's constructor to take in two parameters. We'll make sure that we specify both the texture and the color for the actor at creation time. So our first parameter is going to be of type texture 2D. We'll simply call this parameter texture. We also need a color parameter, so we'll specify a parameter of type color, We'll call this parameter color. Then inside the body of our constructor, we'll set up a few fields, and we'll also make sure that this brand new instance of actor gets dropped into the actors list. So to start off, we'll look here at the actors list. We'll make sure we call the add method and drop this instance of actor into the actors list. Now we need to set up some of the fields, primarily the fields that we're feeding in here via parameters. So we'll start out with the color. So we'll say this dot color is equal to the parameter color, and this dot texture is equal to the parameter texture. All right, now that we know the texture that we're using for the current instance, let's also calculate the origin based on that texture. So that way we can find the center point of the texture by dividing its width and height in half. So we'll do that. We'll store the origin. So this dot origin will be equal to a new vector 2. And this vector 2 will be made up of the x component based on the texture's width. So x will be equal to texture dot width divided by 2. Then the y component of the vector is going to be texture dot height, also divided by 2. All right, that takes care of the constructor for the actor class. So now we can move on to the, I believe it is, update method. All right, all of our actors are going to have an update method that will allow them to take the passage of time into account and express that by simply moving themselves around on screen. So this is going to be a very simple method. We'll have a public void update method. And all update is going to do at this point in time is simply update the position. So that means this actor's position will get moved based on the direction it's pointing and the speed at which it's moving in that direction. So we can say this dot position plus equals this dot direction times this dot speed. And this is really where the idea of direction being a unit vector comes into place, because a direction itself should always have a length of 1, and that way we can multiply that unit vector against the float held in speed, and that will give us a final speed in any given direction. All right, one final instance method we need inside of actor is the draw method. So we'll put together a public void method called draw. We'll take in a sprite batch as a parameter for drawing. So we'll make a parameter of type sprite batch called sprite batch. And grab a little bit of spelling on batch. There we go. Now inside of our draw method, we need to do a little bit of calculation before we begin actually drawing. Currently, we have our direction represented by a vector 2 value. When we go to draw using the sprite batch, we need to express rotation in terms of radians. So we'll need to convert our vector 2 direction over to a radian-based rotation. So to store this rotational value, I'm going to make a local float variable, and we'll simply call this variable rotation. Now, in order to calculate the rotation, we're going to use the atan2 method in order to convert our y and x components out of the vector 2 into radians. So to access atan2, we'll look into math. From math, we can grab math.atan2, where we first take in the y component, and we're going to be feeding in our direction, so we'll grab this dot direction dot y. Then for our x component, we'll have this dot direction dot x. And for the time being, now again, this is going to where some offset will end up coming in, but we'll get back to that in just a minute once we see which direction it's pointing. Now obviously you'll see here that we have an error indicated by IntelliSense here. And the idea, or what it's getting at, is that atan2 returns a double. We're storing rotation as a float so that we can feed it onto draw. So we'll correct this with a simple cast. So we'll cast our double over to a float, then we can store it into rotation. All right, now that we have calculated our rotational value, we're now ready to perform our sprite batch draw call. So we'll grab the sprite batch parameter, we'll invoke the draw method, and then we'll be looking for the 6th overload of the draw method. This begins with a texture parameter. So we'll feed in this dot texture. Second, we need a positional value, which we will feed in this dot position. We have an optional source rectangle, which we're not going to use, so we will specify null for that parameter. For the color, we'll pass in this dot color. For our rotation, we'll use our new rotation variable. For our origin, we'll simply pass in this dot origin. For a scale, we'll use a value of 1f. For sprite effects, we'll specify sprite effects.none, and we'll specify 0f for our layer depth. Alright, that takes care of the draw method for the time being. Again, we're going to have to deal with some kind of offset here with our rotational value because we have a graphic pointing up and instead of a graphic pointing to the right. But let's see this in action before we jump in and try and correct it. Now, before we can see these methods in action, there are a couple things we need to do. We'll need to do some setup, of course, inside of games so that our update and draw methods get called. We'll also need to create an instance of actor in order to be able to use these methods. And again, earlier we had mentioned that we're going to be creating actors based on random positions. So that means we'll need to be able to find a random screen position and point our actor off in a random direction. Now at this point we've got all the instance stuff taken care of. So we're going to go ahead and end this video off, and in the next video we'll pick up on the remaining actor methods. So that will wrap up this video.